Hi everyone, and welcome to the first of two videos on chemical equations and balancing equations. So in this first video, we are going to talk about what chemical reactions are and what some of the rules are for balancing equations. So you have the same study guide with you. Take notes as we go through things. So where we're going to start in the first place is why we write chemical reactions. And the reason that we write chemical reactions is because chemical equations depict what is happening in the chemical change. And there's two ways that we can write chemical equations. One is using words and one is using formulas. So which one would you rather read? Methane burns in the presence of diatomic oxygen to produce carbon dioxide and water. That's a lot of words and that's a lot to sift through. Or we could use the chemistry language to say formulas. We could say CH4, which is methane, plus O2 yields or produces CO2 and H2O. And right now this is unbalanced. But both of these are saying the same thing, the same information, but this chemical equation at the bottom is much easier to read and understand. And so you will be expected to write both of these. And we're going to practice writing those equations from words first. So to do that, we need to know a few symbols. And the first symbol is a plus sign. And this symbol means that this separates two reactants or two products. It's kind of like the and that we use in math, or like they're being added together, or I'm just separating the two. The arrow means yields or produces. Both of those mean the same thing, and this separates reactants from products. So it tells where the reactants are, it tells where the products are. The next symbol there wasn't a sign for, so you'll draw this in, but it is a two-way arrow like that. And what this says is that there is a reversible reaction. Some reactions can go forward and backward. The next symbols have to do with states of matter. And so you can probably figure out what these are, but we'll fill them in the table. So an S means that a reactant or product is in the solid state. So for example, I can write NaCl, which is table salt, and if I put a little s in parentheses after the formula, that indicates that that is in a solid. I have solid sodium chloride crystals that I'm using or working with. An L is a liquid state. So for example, I have water, which I commonly use, and water we know at room temperature is a liquid. G stands for gas, gaseous state. For example, I can see carbon dioxide at room temperature would be a gas, so I'd put a G in parentheses. The next symbol is something new maybe. AQ stands for aqueous. And what aqueous means is that something has been dissolved in water. I've made a solution of it now. And so a way that I would write this would be I can use NaCl from before, but if I put AQ after it now that means that sodium chloride has been dissolved in water. I don't have it as a solid anymore. It's been mixed in with water. So watch out for that AQ symbol. The last symbol is an arrow with a triangle over it, and that means that heat has been added to the reaction. Okay, I'll draw your attention to these 7 diatomic elements right below here. These are 7 diatomic elements that you need to know. And what this means is that as free elements, these 7 exist as 2 atoms covalently joined together into a molecule. They don't just exist as free atoms, they're actually tiny molecules of 2 atoms joined together. So an acronym I like to use to remember those 7 is Brinkelhoff. And you can pronounce that, Brinkelhoff, and in it, it has all 7 of those diatomic elements. Maybe you want to put a star in those elements on your periodic table to help you remember them also. So let's do some practice writing chemical equations. So in each of the following sentences, we're going to translate from words into formulas and symbols. So let's do the first one. When you put pieces of calcium metal into hydrochloric acid, it makes dissolved calcium chloride and hydrogen gas. And I'm just underlining my substances as I read that so that I make sure I include everything in my equation at the very end. So let's start putting the pieces together. I have calcium metal. Okay, that's Ca. And now I check. That's an element by itself. Is it one of the 7 up here? It is not. And so I'm just going to leave it as calcium. It doesn't get a little 2 next to it. And that is being reacted with hydrochloric acid, and that formula is HCl. It makes, so that means I draw my arrow, dissolved calcium chloride. Okay, now I have to recognize that that's a compound, an ionic compound, so I have to write my formula correctly. Calcium has a +2 charge, chloride has a -1 charge. So when I add the right number of ions that I need, my formula becomes CaCl2, and that's review, guys. And that is also with hydrogen gas. Hydrogen is an element. Is hydrogen one of the 7 up here? Oh, yes it is, so it should be H2. And then I can go through and write my states of matter. There's some clues in here that tell me things about the situation. So calcium metal means that that's a solid. Hydrochloric acid is always a solution. Dissolved calcium chloride, so I have aqueous solution of that as well. And it tells me that I have hydrogen gas, so I'll put a G for gas after the hydrogen. Okay, I'm going to leave it unbalanced for now, so we're good to go with that for our chemical equation. So let's do the second one. This reaction says solid sodium reacts with water to form sodium hydroxide solution and hydrogen gas. So I'll do the same thing here. I'll kind of put them in order. It says solid sodium, so that's Na. If I look back on the previous page, sodium is not one of the 7 Brinkelhoff elements, so it doesn't get a little 2, it's just by itself. And it reacts with water to form sodium hydroxide solution. That's another ionic compound, so I have to write the charges for that. Sodium is a plus, OH is a minus. Put them together, I get NaOH. And hydrogen gas. Hydrogen we saw from before was a diatomic element. I'm going to go through and put my states of matter in. Sodium is a solid. Water is a liquid. Sodium hydroxide, it tells us, is a solution, so I'll write AQ. And hydrogen is a gas. All right. Be careful too that you're interpreting these other words like to form, reacts with. I mean, that gives you clues as to what order I should be putting things in. So don't necessarily just go by the first things that you see, but look for those other clues that tell you if something's being produced or reacted with. All right. So now you've got 3 and 4. I want you to try these 2 on your own. So pause the video, give those a try, and we'll review those in class tomorrow. All right. This might also be a good time to pause the video and make a prediction about what you think it means that an equation is unbalanced. We've used that term before up until now, but what does it mean to say that something is unbalanced? Pause the video and make a prediction about that. So after you've done that, these are the reasons why we balance equations, and they really are the same thing. It's just different ways of saying it. So the law of conservation of matter tells us that atoms cannot be created or destroyed. And this comes from a chemist and scientist named Lavoisier, who had a really big influence on John Dalton. This was part of John Dalton's atomic theory from back in the 1800s. So this is a huge, huge idea in chemistry. What this really means is that you are conserving mass because atoms have mass. And so another way to say this is mass cannot be created or destroyed. And maybe just another way I can write that is that the mass of my reactants has to equal the mass of my products. So I shouldn't lose or gain any mass from a chemical reaction. They really should be the same from start to finish. So if I look at a quick example with that, in the complete reaction of 22.99 grams of sodium with 35.45 grams of chlorine, what mass of sodium chloride is formed? So what I'm really doing is adding sodium with chlorine, which is Cl2, to form NaCl. And I know if I have 22.99 grams of sodium and I have 35.45 grams of chlorine, if this is the mass of my reactant side, then the mass of my products should really be those two things added together. So if I add those two up, I get 58.44 grams of product. So that's what that's showing us here, is that mass of reactants equals the mass of products. All right, so when we balance equations, they will show us the following things. They will show us what reactants were combined and how many of each reactant were combined. And the same thing for the product side. They will show us what products were produced and how many of each product were produced. And so we'll go through a few guidelines for how to balance equations, some tips and tricks to help us successfully balance equations. So here they are. We need to first determine the correct formulas for all the reactants and products in our reaction. And this really is an important first step. If these formulas are wrong, the whole balancing of the equation will be wrong because we can't start at the right place. So all those skills we learned from before, how to write formulas for ionic and covalent compounds, are really coming back in here. You have to have correct formulas. And we are going to put the reactants on the left and the products on the right. We will separate them with our arrow, which is the yield sign, and equations that have two or more reactants or products will involve the plus sign like we've seen before. So our next tip is to count the number of atoms of each element for the products and the reactants. I will just make a table, keep stock of what I have to start with. Another tip for polyatomic ions is that I will want to keep them together and I will want to treat them as a unit. And in the next video we'll see what we mean by that. But for right now, look for those polyatomic ions, and if they stay together, we'll keep them together. All right? On the third page, one at a time, we have to balance our elements using coefficients. And these are numbers in front of the formula. And these are really, really important numbers because what this says is you cannot change the subscripts. You cannot change the subscripts on formulas. You might want to highlight that or underline that because that is a really big idea. You can only change the coefficients. What that means for your math is that coefficients are multiplied by the subscripts, okay? After we maybe have balanced one of the elements, I will need to recount. I might need to keep doing steps 3 and 4 a couple different times until every element has been balanced. So I always have to recount each element to see what has changed. If there are still changes to make, then I have to keep balancing every element. And the last But really important step also is to make sure that all of the coefficients are in the lowest possible ratio. If they're not, I will need to simplify or reduce my coefficients so that they are in the lowest possible ratio. All right, so this is the end of video 1. Video 2 will show you how to balance a few equations, and then you'll try a few on your own. All right, we'll see you guys tomorrow in class. Have a good night.